All right, let's make a solid model of the corner stop and follow it up with a model-based definition as well as a drawing of the front, top, and right views. I'll make this in three separate videos to make it easy for you to jump around. So this first part will just be the solid body, and then we'll do the dimensioning of that solid body. Let's draw the bottom base roughly out in space, and I could see that a distance of 2.25 would be good to start off on right here. Lock it in, 2.25, zoom back, move over, escape, move this one over, and we really don't want that many decimals. Units, modeling, maybe the angle, we can do that as well. All right, the next shape you can see is going to go down to the right, then it's going to go over and then make an arc. Let's do all of that. All right, here we go. So just an arbitrary distance down here, but definitely horizontal here, like that. Sometimes you can go like this and it will put an arc in place, but I don't see that happening. In this case, what we can do is come over here, do a center point arc, and I guess we could find the center there. I'm just going to place it. You know what? Maybe a better thing to do is just to go all the way across and then turn that into a construction line. Now that distance is going to need to be 4 inches, like that, if I'm seeing that right. Yeah. And then I need to go, let's see, all the way back over. Right. Okay. So the first thing we want to note is that this needs to be back at the starting point. So we will do coincident here and there. And then the other thing is, let's see, that needs to be 4. That needs to be 2.25. That's looking good. We want to make this right here a hidden line. And then the center point arc is going to be at the middle of this, but not hidden. From there, start here, go all the way over there. Is it fully defined yet? Not quite, because we have to get a couple of these other dimensions in place, and that would be this angle. And you notice you can't lock into that to get that angle, but you can lock in here like that and then pull it out this way. So one way to get around the constraint. So let's see, it needs to be 60 degrees. And we really didn't need that many decimal places. We just needed one, apparently, according to the expectations in the problem statement. All right, now this looks like it went way over there, so we don't even have that distance visible, but we can just stretch it out manually. And then look at the distance right here, which is 5.25. That's from the center all the way over to this edge, 5.25. Is it a fully defined part yet after we get the 5.25 in place? Fully constrained. We want to add everything else that's on the bottom plane, and that would be a cut right there and a circle over here. Let's get some dimensions in there. 3/4 of an inch. Click, click, 0.75. And then over on this one, we have a diameter of 1.25. That's fully constrained, but not this one over here. Want to place it a distance of 2 inches from this edge that we haven't drawn yet. But also we want it to be a distance of 1.25 from that edge. Let's go ahead and put that slope or that drop off, that cliff in place just by drawing it like this. And so we'll do 2 extrudes. We'll extrude this bottom face and then this top face and then start cutting other things away as needed. Now, it looks like the distance from the center point back to this cliff right here is going to be 1.25. So it's from center point to this one. I have it on that side for some reason. And because they didn't really give this as 4, I am going to delete this one just to try something out because it should take us away to, we hit Control Z for a second. Oh, there's one dimension missing still. Oh, that's the placement of this guy. All right. So let me go ahead and delete that 4 like I was doing. Because really over here, they give us the radius of this arc. So let's just change that up to be more like what we have. And you can see that it's going to be exactly 2. And now we're back to fully constrained, except for the one distance, and that is the distance from here to over here. And it said that that was going to be exactly 2. Now we have a fully constrained sketch that we can then extrude upward using the Born approach. And we'll do a 2-step process. The first one will be where we, oh, where'd it go? We want to extrude this front piece out here, like the toe of it right there. Only a distance of, let's see, what is the thickness right there? All right, so this right here is 1.5, and this right here is 2.5. So it's just going to be 1. Now we can say I want another extrude for this other piece. We want this one to come up a distance of 2.5. So that's the benefit of using the Born approach, is we get all of that in place. Clicking the home button, you see that we're not correct on the orientation. So remember that the way you fix this so that this is rotated properly is you have to reset the home position. So this home position is not correct. We're going to click on this corner to make it look like that one. And then we're going to right click on the view cube and say reset the current view as home to fit the view. Okay, so now anytime we hit home, it's going to be just like this. The other thing we want is we want this to be the front and this to be the right and that to be the top. So we don't really have it like we want. So we want this to be the front. So let's look at that face. And it's really the right face here that we want to redefine, set current view as front. And so now if we go back home, it looks like it should. It looks like it's got the isometric view here with the right side here, the front side along this direction, and the top up there. Looking real good. That's going to be good news for us as we get into the model-based definitions and the drawing. So let's go ahead and do a sketch on this surface. And we will put that arc in place. Center point arc along this edge. Can we find the center? Sure. And then we come over here, lock, and then lock again. And hopefully that worked out and had us, gave us enough constraints. This is going to be 1.25. And it says one more dimension needed. We can hit escape a couple of times and see that probably I didn't, yeah, it didn't lock like we wanted it to. So in that case, you come up here and you say, I want this piece, the end point to be coincident with that one before we perform a cut of probably just about an inch. Let's see, oh, about less than that. Okay, so we're going to do a cut in 0.75. Okay, there's one other thing we need to do, and that's to put a chamfer looking thing on the back side. The only thing is they don't really give us that distance, so we'll have to have it be implied that it's there. We can draw it on the back plane or on the middle plane, but we can't draw on this surface because it needs to be perpendicular to this back plane. So I'm going to try maybe just doing a sketch. You know what? How about just on the back side? So we can rotate the part around. Let's see. I think we want to go around to the other side, right? So if we click this one, we can now draw a triangle on this side and then cut on through. Break on through to the other side. Okay. There, there. Dimension between here and here. We want that to be 45 degrees. And then the distance from where it hits the top and where the ledge is which I think is right there, is going to be 3 inches. So from that point there to this point, or maybe that line, it's going to be the same thing. That needs to be exactly 3 inches. Does that give us a fully defined constraint? Yeah. Do we know how far this is? I'm kind of curious as to what it is. So we could measure it like that. And if we see that it's exactly 1. Now I'm not sure how to imply that from all these dimensions, how we could get 1 from that. If I go up here and say yes, it will put it in parentheses, but we don't need that dimension. We found that that dimension was inferred. Going back to the home position, or maybe going back to that one because we forgot to do the extrude cut. This is the shape that we want to cut. I kind of knew that already, and we want it to be through all, wait, through all. There it is. Then going back to home. I'm a little bit worried that we don't see this, backside right there, just a little bit. Let's see. We don't see that, but it might be that they're using a trimetric instead of isometric view. So we will not worry about that until we get over to the model-based dimension to see if we made any mistakes. Okay. All right. I'll see you in the next video.